Hello and welcome to today's webinar entitled How to Retrofit a Snow Melting System. My name is Scott. I am from WarmlyYours, and also we have Anatoly on the other end. Hello, Anatoly.
Hey, Scott. Hey, everybody. My name is Anatoly, and I'm with WarmlyYours tech support and product team.
So we are going to be going through our webinar today, and we will be discussing how to retrofit a snow melting system for a heated driveway. This is going to be a lot of great information. We get this question all the time on the phones. So if you have any questions during our presentation, please feel free to click on the Ask a Question section. And it sounds like our sound is not good. Olivia, our person behind the scenes over here, is going to be checking on what's going on. Does Scott sound okay? Does Scott sound bad? Does Anatoly sound good? Does Anatoly sound bad? That might give us an idea of whose microphone, or is it just bad for both of us? So just let us know. So if you have any questions, feel free to go ahead and type those into the Ask a Question section. Okay, thank you, Mark. Diane says sound is great for me. So I'm going to take that as my microphone might be okay, and we will work on Anatoly. So I'll let Anatoly expound about something really quickly here when we get to our next slide. So let's go ahead and move on to our next one. And what we'd like to do is talk about the following items in the webinar today, and that is heated driveways, preparing the existing driveway for the retrofit heat, and then actually installing the retrofitting snow melting into that actual surface. So Anatoly, we're going to do two things right here. First of all, we're going to see if your mic works, if you sound okay. So go ahead in just a second. And what we're going to do then is we're going to have Anatoly tell us about what's going on with the snow melting systems and what products are we using here. I see we have cable and we have mats. When are we going to be using those?
Sure, I'll be glad to cover that. And I hope my mic works fine, because that's like one of my favorite topics here, just because of the sort of complexity and just interesting approach to the whole installation. So snow melting systems that WarmlyYours provides are snow melting cable and snow melting mats. The mats are typically 2-3 feet wide and would be used for larger, different applications. In our case, we're mostly going to be talking about snow melting cable and how to use it in this retrofit application for under concrete or asphalt.
Great. So it sounds like we have our sound going. We got some good reports there, Anatoly. So you sound great, and thank you for that great information. Total home run on both items. So let's go ahead and take a look at a heated driveway. A lot of people don't even know that you can heat driveways. There are a couple different ways of heating driveways. What are we going to be talking about today? I love this picture.
Yeah, definitely great picture. And of course, as you can see, it's a comparison picture between a melted driveway on the right with a heated, snow melting heating system installed, and the non-melted, or I should say non-heated driveway on the left here. And of course, the picture on the right shows you an operation, or an actual operation of that snow melting system that runs most likely, in this case, completely automatic. So when the snow just hits that sensor triggers the controller, and the system just runs, heating that particular driveway and walkway combination. And in the very end, as a result of that, you have the surface that just never accumulates any snow, because it just melts, turns into water, evaporates partially, and just gives you a nice, free of snow, safe walkway and driveway.
Yeah, there are lots of different ways of controlling the product, all the way from a manual dial timer to a Wi-Fi controller to having something completely automatic, where if it begins to snow and it's under 38 degrees, the system will come on automatically. When it's done, it'll then operate for a while to completely melt the snow and to get rid of the water and to get rid of any pools or any slippery parts, and then it will shut off. And that is done automatically. So you really have your choice of, do I want to turn the knob, or do I want it to do it all for me? So when do we use an installation of this type with a retrofit?
So generally, the retrofit type installation would be, I mean, the perfect time of it for installing that type of system, of course, can be from late spring to late fall. So during the kind of still normal temperatures, you don't want to deal with that when it's freezing outside or snowing outside, of course. And in terms of the type of the surface, you really would be looking at the more relatively new driveways, the one that doesn't need to be replaced anytime soon, because it doesn't make much of a sense to kind of start digging into a driveway, which again, we're going to cover that process in just a few slides, but start kind of cutting out the channels into a driveway that maybe going to be replaced in a year or two. You know, you would really look into systems, into the driveways, walkways, or whatever that surface would be that was maybe recently installed, but that system was, again, not installed or forgotten, or maybe the homeowners changed the sort of decision on using the system.
Yeah, what you want to do is you want to talk to your concrete guy or professional, or you want to talk to your asphalt professional and ask them what the condition of your current driveway is. If they say, you know, this needs to be replaced in the next year or two, you definitely don't want to do a retrofit into that. You might as well go ahead and take it out and put it in, because it is easier to install if you're redoing your driveway than if you're doing a retrofit, just because it's just easier to get it in and to manipulate around it. The thing to keep in mind is that if your substrate, which means your old driveway, if it begins to break up and crack and splinter and that sort of stuff, that can actually damage the cable. The cable is very, very resilient. It takes temperatures of over 300 degrees. You can walk on it when it's being installed. It's very, very strong. However, when the product that's it's installed to starts to degrade and fail, if that failure is very, very catastrophic, you can also damage the cable. So you definitely don't want to put that into a system, into a driveway that's going to be needing to be replaced in the near future. It just doesn't make any financial sense. So that is the time to do it. You just moved into a brand new house that somebody else didn't want it in, but now you want it in. That's a perfect time to do a retrofit. So there are a couple different types of retrofits to do. The slides that we have are showing you how to do tire track coverage. That means melting for each set of tires on a car. If you're a motorcycle person like myself, that means you could get 2 motorcycles down the driveway if you had to. That's what tire tracks are. But you can also do entire areas, like you can do the entire part of the driveway, or if you have a tennis court or something like that you want to heat the entire area, you can retrofit that in. You just need to make sure that you make your cuts in the entire area that you want to heat. So what we are showing you right now, this is tire track coverage. So that's what we are going to be discussing, because that's what a lot of people do. Because retrofit work there is a lot of work to it. There's a lot of cutting, there's a lot of bending, there's a lot of pushing cable manually and that sort of stuff. So the perfect thing for retrofit usually is tire tracks, but you can do whole areas. So what we're doing now is just tire tracks only. So what do we need to do, Anatoly, when we're talking about getting started with this project?
Yeah, so definitely a great slide. That I like that, since that's really, your overall start of the application, overall preparation for the whole thing, and really the number one thing you really want to be careful and watch out for is all of your gas, water, electrical lines. And for that, just contact your local utility to mark any of these lines, or pathways, to make sure that you're not cutting into those. And then really the next few steps would be to follow the smart plan that we provide, where we already pre-plan for you where those tire tracks would be, or where that full coverage would be, and start kind of positioning that area where it actually falls onto your driveway or onto your overall area there. And really the rest of the process is pretty simple. You follow the smart plan that we provide. You mark the kind of start and end points of your cuts. You mark each groove or each channel that's going to be cut there. Spacing is very crucial part. You want to make sure you maintain the right spacing. Typically it's 3 inches, but it might be an application with a 4-inch spacing or so. And after those are, the lines are done with the chalk marks, then you can use the spray paint over those, just to kind of gives you additional clear lines, so in case the chalk marks will wash away, you still have a nice clear line to make sure that the cut's going to be done just in the right places.
Okay, great. So let's move on to the next slide. When it starts to talk about supplying electricity, because these cables obviously use electricity. So we have to get the electricity from the house or from the service area out here to where it needs to heat. That's why it's so important that you call the Julie. If you're in Illinois, they call it Julie, the Joint Utility Locating something or other, blah, 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 whatever they are. And you call one number and they do the marking for the gas company. They do marking for the electrical, cable. All those marks are done by this one group. They will come out, because what happens is you are cutting into this driveway and there may not be any power or gas under the driveway, but to the left or the right where the electricity has to be put in to the driveway, there may be something there. On one of these jobs that we did, we actually had to get the horizontal borer out, which is a guy on a machine that bores sideways and does that under the driveway to come out to the other side. And that's where the locating of the electric is so important. Hey, if there's electricity over on this side, you can't bore over there. You need to bore over there. So that's why it's so important. You may think, no, I know where everything is. You don't know what they're going to have to do to locate these junction boxes and to get the power to these particular heating products. So always call the locating device. So let's go ahead and talk about, first of all, what is a junction box? Why is a junction box even needed?
So yeah, junction box is eventually an enclosure where you, electrician in this case, will be connecting the existing cold leads that would be coming from the heating cables and extending those and connecting them all the way to the power source, which eventually going to be somewhere indoors, either in your garage or some electrical room. So I would just call the junction box as your enclosure where that extension is being done. And that's where, again, you want to make sure you discuss all that and plan all that with electrician. So he specifies maybe for us first where the junction boxes will be, so we can prepare the right plan. And then eventually a cutting person, the contractor who's doing all that concrete or asphalt cutting, will do those additional cuts for the cold leads, and everything is planned and everybody on the same page.
Yeah, it's very, very important to realize that the cold leads are only a specific length. So for 120 and 240, they're only 20 feet long. And for 277 and 208, they're 50 feet long. So those extensions, those power supply wires that are non-heating that run over to the heating wire, those you do not add on anything to. You can cut them if you need to, but that's the non-heating leads. But you never make an extension inside of the driveway. You simply get those cold leads out to the side of the driveway through conduit. You get it into a box. You cut the cable to the correct length inside of the box. Some local codes require a foot. Some local codes require 8 inches, some 6. It all depends what your local code says that you have to have available coming up out of the box to make your connections. And what that is simply a box that you make your connections in. The connection between the heating cable, which is out in the driveway, and the wire that runs from this box to the house, because the electrician is going to be supplying the electrical wire that runs from this junction box back to the house or wherever the service entrance is. So that's very, very important. Also, cold leads should never be just sent out the side of the driveway, not covered. National Electric Code says that conduit has to be within 4 to 6 inches of the actual splice. The splice is the non-heating lead to the heating lead. That splice has to be within 4 or 6 inches by the national code. So really what you're doing is you're running conduit. As you can see from this picture at the bottom, you can see that conduit is running into this box, and it's running over through the cut in the driveway over to where the factory splice is. That's how the local code, that's how the National Electric Code says it needs to be done. And of course, whenever you're doing a job like this, you always want to discuss all of this stuff with your local authority having jurisdiction, which is the name for your local code official. So it's very, very important that you get all these rules down to make sure that it's done the correct way. That's why we always strongly suggest that an electrician is done for this, because the electrician is first of all going to be licensed. He's going to be insured. and they are also going to know what the local code is. So that's where we come from when it comes to what a junction box is. Very, very important to realize what its job is. And we're going to show you where those go when you receive the smart plan from us. It'll be a circle with a J in it. That's the junction box location. So this is a great slide. This is a lot of stuff that people always ask us and we've never really talked about, but this is a perfect time to do it. So I'm going to step off my soapbox now, and we're going to go to the next slide. So this is where it comes down to getting dirty. We're going to be saw cutting the main lines. So talk about what's going on here, Anatoly.
So yeah, so that's kind of just generally, I would call it a next step, the second step of the whole process, where eventually all the lines are marked, everything is planned, we know what needs to be cut into here, and eventually the concrete cutting contractors, the contractor will start cutting those lines. The important thing here to share with, again, kind of be all on the same page with that concrete cutting contractor is, first of all, number one, that the cuts for the heating cable itself should be 3/8 of an inch wide. The reason behind that is, of course, because the cable itself is about 1/4 of an inch wide, and you want to make sure that there will be enough room for that cable to easily go into the groove without, any pushing and kind of bending that cable into it. So 3/8 inch wide cut is what's needed. The cuts itself will need to be at least 1.5 inches deep, but they can go as deep as 2 to 3 inches. So it all depends maybe on the surface or how deep is the initial pour of that concrete or how deep is that asphalt here. And then those wider cuts for the cold lead that we were just talking about in a previous slide, those cuts, again, those going to be wider because the cold lead is a little bit wider, and those cuts needs to be 9/16 of an inch. So again, that's going to fit the splice and the cold lead into there to make that transition. Like Scott mentioned before, you want to make sure that that splice sits at least 4/6 inches away from the conduit. Never push it into the conduit or anything like that. You want to make sure it's fully embedded because it's still partially heated. So you want to make sure that it never overheats by just being, kind of sitting in the conduit in the open air.
Yeah, it's very, very important to keep in mind that the heating wire never, ever goes in conduit. And since the splice is half heating wire and half cold lead, it cannot go in the conduit either. So, excuse me, it's very, very important that that never gets done. Also, if you have an in-slab sensor that you're going to be using, since if you have asphalt, we strongly recommend that you put an in-slab high temperature limits sensor in, because if asphalt gets really, really hot, it can start to degrade and turn soft. That's what that high temperature limit sensor is for. If you're doing this in concrete, that's not needed because concrete won't get hot and melt. One thing I want to point out to you, this cutter here is shown here. You can see the blade is kind of like a greenish color here. Most of these cuts were done with actually 2 blades right next to each other, right?
Yep.
So that's what you have to do to get the correct width. So I believe maybe in one of these cuts, they actually put 3 blades on to do the thicker area where the factory splices, because it's fatter than the other parts were. So one thing, I'm going to give you this free piece of advice. If you do this job, you're going to get the drawing from us, the smart plan. And when you get the smart plan, it'll show you how long the cable grooves have to be cut. I'm going to give you a little bit of wisdom here. This groove over here was shown to stop somewhere here. We said, hey, you know what? Put 5 or 10 feet longer groove in there, because it's very, this is the time to do that. And if you miscalculate the amount of, if your runs aren't quite long enough, or if they've turned out to be a little bit shorter, then you can't cut the cable. You cannot cut the heating cable. So now all of a sudden, if you have 2 or 3 feet of extra cable left over, if you don't cut the extra right now and plan for it and just fill it if you don't use it, you are going to have this guy have to come back out to the job site and start cutting again. And that's the last thing you want to do, because this guy in the summer is really busy and he may not be able to come back tomorrow. It may not be next week. It may be 2 weeks from now. And all of a sudden your job has come to a halt. simply because you have too much cable for the groove that you have cut. So when you have these grooves, my suggestion is 5 to 10 feet extra, have them cut it, because if you don't use it, that's fine, perfect. You just go ahead and fill it in. But if you don't have it, you're going to go, oh, geez, what in the world did I do? Now we're going to have to wait for this guy to come back. So that's, that's very, very important. Having this guy come back out again is going to cost you money. So that's one thing that you don't want to do. We had a couple of questions from Paige and from Cliff, and we were going to talk about them in a slide or two before this, and we missed it. But Paige had a great question that we get all the time. I just answered this question this morning. Is it suitable for decorative gravel driveways or gravel driveways of any kind? No. Snow melting, the products like this are not rated for gravel driveways. And can the driveway be a rock driveway versus asphalt or cement? Asphalt or cement driveways are the ones that you're going to be retrofitting. And you're not going to be installing it in gravel. So those are two great questions, Paige and Cliff. I just wanted to make sure that we didn't skip over those. And then the next question was from Sean, and that was, does this work with concrete driveways? And yes, it does. We're just happen to be showing you an asphalt job that we did close by, but this can also be done in concrete. So let's go ahead and take a look at our next slide, and we will go here to talking about, we've shown already the cuts that we're making for the cable to fit in, but the cable just doesn't magically get from one run to the other, does it?
I definitely will not do that. So that's where those U-turns needs to be saw cut as well, and needs to be nicely planned for. And in this slide, yeah, definitely great slide. We are going to show here two different options, two different methods on how that can be done. I mean, one sort of basic, simple method, I would call it, you can just take one of those like a handsaw and start cutting 45-degree angles. So, you know, you cut one 45-degree angle, another one, and that kind of almost gives you that U-turn type of, I would almost call it a V-turn sort of shape, which still can be done. And as long as it's wide enough for the cable to nicely make that transition, that should be okay. So that's one method on how that can be done. However, you can also do a core drilling shown on the photo below. And the only thing to plan here would be, of course, to make sure that your contractor will have the correct diameter of that for that core drilling, and that diameter should match exactly your cable spacing. In other words, if the cable is typically spaced 3 inches apart, you want to make sure that that core will have 3-inch diameter. So when you're doing this core drilling, you're creating a nice U-turn for every every section where the cable need to make a U-turn and go into the next line.
Yeah, and there's each one of these methods has its pluses and minuses. The core is actually you're cutting a circle at the end. The other one is just you're cutting 45-degree angles. So bending the cable is easier with the core because it's round. But the problem is you're going to have more patching that you're going to have to do with asphalt to fill those holes. Once you get the cable in, you're then going to have to patch that 3-inch hole with asphalt. The other, the V-shaped 45-degree cuts are, you don't have to worry about that. However, it's going to be a little more difficult to bend that cable in that 45-degree angle because it's really a 45-degree angle at each end of the run, but it's 90 degrees at the top, at the point of that. So that's where you're going to be very, very careful with the method that you choose. Now, you need to make sure once you get this cutting done that you clean the grooves out with a high power pressure washer. And then invariably, you are then going to have to go behind that, and you're going to have to go into each groove with a screwdriver or something like that to clear out any debris that might have, while you were spraying this one out, it might have sprayed into the other one. So then at that point, you're going to be going through there with a screwdriver. My suggestion is a flat screwdriver. And then you also make a mark with a piece of tape, like similar if you're drilling something and you need the hole that you're drilling to be 3 inches. What you do then is you measure 3 inches on that screwdriver and put a piece of tape around there. at that 3 inches, you can then drag your screwdriver through that groove, and you can see if you're maintaining 3-inch depth by seeing where that tape is on your actual screwdriver. So it looks like we have a question. Did we say questions were allowed for this one or not?
Yeah, for sure.
Okay. Yeah, so we love questions. Do you need okay, so I need to start answering this question. Do you need higher capacity on a retrofit versus a new installation when you can put insulation below? First of all, when it comes to electric heat, insulation below is not required because you're not using hot water, which after, if your hot water is hydronic, and as soon as that water leaves the boiler, it starts cooling off. And by the time it gets out to your driveway, it's much less warm than it was when it left the boiler. That's why hydronic systems always recommend using insulation. Since electricity is the same temperature at the very beginning of the cable as it is at the very end of the cable, you don't have to worry about putting in insulation. So that's what's so good about electric is you use the same capacity, you're using 3-inch spacing, and that's what we normally do. And you don't have to worry about that insulation below. Was that correct, Anatoly?
Yeah, that's actually an interesting and a very good question. I like it because, yeah, it kind of just proves the whole point that when you're doing the retrofit, you're really putting the cable in exact identical same spot as you would do during a normal brand new installation. In other words, the depth is the same, the spacing is the same, is just you're doing that after the driveway is being done. So yeah, I would say there's absolutely no power differences here.
Very good. Nice question, Paul. Thank you for that. Okay, so I am going to continue on here. Be sure that the grooves are dry and free of debris before you move on. So that is going to be our next slide, and we're going to move on. So let's talk about, oops, I'm going to click on this instead. And let's talk about testing the system. What's so important about this? Why don't we just get the cable and throw it in there?
So yeah, testing the system is definitely a crucial part of the whole installation. You want to make sure that the cable is tested throughout various steps, and I'm going to be talking about those just in details in a moment here. The important part here that I want to point out is we show that those two devices at the very top of the slide, the regular digital ohm meter, which typically every electrician would have, but in addition to that digital ohm meter, your electrician need to have a mega ohm meter. That's a device, another name for it is an insulation tester. In other words, it tests the cable at a higher voltage just to give a better level of reliability to understand if there is absolutely no damage in the outer sheath of the cable. So testing the cable with those two devices throughout the installation is very important. And I always like to point out is good kind of idea is always to test it before and after every major step of your install, including the time when the cable just got delivered to you. It can potentially be damaged in the UPS truck. You never know. So test it there. Test it right before you installing the cable. Test it periodically throughout the installation into the grooves. Then again, test it maybe right before the patching will be done or so. So periodical tests here will ensure that cable is in 100%, 100% of its quality. Nothing got damaged, and you will be sure that everything's going to work just fine.
Yeah, when you're getting ready to talk about this project with your electrician must have a digital ohm meter, and they must have access to a mega ohm meter to use on the day of installation. If they don't say yes to both of those, then you need to find somebody else, because the mega ohm meter and the ohm meter are required steps to make sure that you get good warranty coverage on the product. So let's talk about actually laying out the cable. So what do we have here?
Yeah, so the next step, I would probably call it step 3 if we're talking about the major steps. So after the grooves are cut, they're prepared, and those are nicely cleaned, and those are nice and dry. That's eventually the point where you just start laying the cable. You can follow the smart plan just to make sure that you're on the right track. Keep an eye on that halfway mark to make sure that the cable, that you're on the right track, that nothing is going like, nothing is going too short or too long on that cable length. But generally speaking, your cuts are made. You're just laying the cables into it. A good tip here, make sure that further in the steps, I probably want to share that, but when you're laying the cable, make sure that it sits nice at the bottom of that groove. You don't want to have that cable kind of pop up a little bit and sit on the top of that channel, because eventually when you're getting ready to embed that cable, and again, we'll have a nice slide for it, but you want to make sure that it sits at the bottom. You don't want to stick it up to the top and kind of transfer that heat into the upper surface. You want to really heat a little bit lower below. So yeah, when the cable is in, keep an eye on that factory splice, of course. Make sure that it's in the right spot. Make sure it's not too close or in the conduit. Yeah, I mean, be careful when just laying the cable in. Don't try to like pull the cable to slide it through the grooves or anything like that. You might be dealing with still sharp pieces of stone that was just cut inside the grooves, so you don't want to have any unnecessary damage there.
Yeah, when you're doing this, you're going to take your screwdriver that you use to clean out the grooves. You're going to take that screwdriver and you're going to throw it into the neighbor's yard, because you don't want to use that screwdriver anymore. What you're going to do now is the best thing to make sure that the cable is down in the bottom of the groove is to take a wooden dowel. That's a 1/4-inch wooden dowel and push it down and use that as the tool to go ahead and push it down into the groove. That's what you want to do. You definitely don't want to use that screwdriver that you use to clean the grooves out. So what we've shown you now was the process of cutting grooves into the surface and then retrofitting the cable down into it. That's what you can use in all of your retrofit jobs, be it just tire tracks or the entire area that you want to heat. The next thing we have here is a method that you can use if you're doing tire tracks. So what's going on with this tire track installation?
So yeah, that's I would call it alternative tire track installation method. The reason, kind of the whole process behind that method is that instead of the grooves, if you have access to the right machinery, to the right equipment, or the contractors, of course, has access to that, you just trench out sort of a larger channel. I would call it a trench, and it should be 2 feet wide, because that's the width of the snow melting mats that we offer. And as long as that trench is made and it's at least 1.5 inches deep, or maximum up to 2-3 inches deep, that's where the whole heating mat can go in. So now you're not dealing with just individual cable runs. You're just placing the whole mat that is 2 feet wide, and eventually it will be covered with asphalt. So it's just a different alternative approach to pretty much getting the same application, the same system.
Yeah, it's just a different way to go ahead and get that in. This way you would be cutting into the asphalt, or and once again with concrete, it'd be very difficult to do this with concrete, because you can't. You'd have to talk to a concrete professional on how to get down 2 to 3 inches and make this cut for you. But I do know with asphalt, you can make these cuts with the same cutting tool we've seen. Then just take a spade, a shovel, and stick it in there and start pulling them out, giving you that nice cut down each tire track. So now that we talked about the 2 ways of getting that heating product into the actual spot we're going to be heating, now we need to worry about all the peripheral things that have to go on, kind of like the collateral stuff that needs to be done. So what's the next step?
So the next step is make sure to embed that manufacturer splice. And I feel like I already mentioned that like 3 or 4 times, but we love the factory splice. We want to make sure that there's extra care is taking care of that splice, that nothing is bent, nothing is damaged, and that splice is fully installed. So once again, just to recap, the factory splice is that connection. It's about 4 inches long or so, and it's that connection spot between your green heating cable and your black non-heating lead. And that's the splice which eventually you don't want to bend it. You want to make sure it's installed in the groove. You want to make sure it's going to be fully embedded. Again, the last thing you want to have is electrician, seeing the splice, seeing it's the same color of the cold lead, and just like treating that as a cold lead or regular wire and just pushing that into a conduit or something. So again, make sure everybody on the same page. Splice is covered. Avoid stepping on it or applying any extra pressure on it. Just be careful with it.
Yeah, do not try to bend the splice to get it to fit somewhere, because if you bend it, you have a pretty good chance of damaging it. That's the one spot in this whole assembly that you have to really, really take care of, not to try to move it around too much. The other stuff, the non-heating lead and the heating portion, are very, very rugged. You don't really have to worry about them too much, but that splice, you don't want to be bending that and messing around with it. So let's talk about the next thing. And the next thing is we've now put the cable down. We've done the cuts. We put the cable in them. And now what's the next step?
So the next step is pretty much almost like I would call it almost the final step, because really what you're doing now is just filling those grooves. Because remember, the whole idea is we always want the whole cable being completely embedded and of course the cuts completely filled. So in our case, because it was an asphalt project, those cuts would be filled with a hot asphaltic sealer. That's eventually for those asphalt retrofits projects. And for the concrete projects, that would be like an expansion joint sealer that will be covering all the grooves. If it's a asphalt project, a top seal coat is not necessary, but of course it can be applied for just nice aesthetic reasons. So eventually, if you're, let's say, planning to kind of have that top seal coat done later in the year or before the winter starts, and you're also planning to have your snow melting retrofitted into your existing driveway, that's where it's important to kind of plan these steps in the right sequence. So eventually do the snow melt retrofit first, cover the grooves, and then eventually when the grooves are covered, you can then plan that final step as the whole seal coat of maybe the whole driveway.
Yeah, the thing to keep in mind is this, the step that we're showing you right now is not done with that stuff that you buy in a tub at a big box store. That's too thin for this application. This is actually very, very thick. You can see that it kind of rolls up in the applicator. It's very, very thick. You may have to do 1 or 2 passes to get it to fill in there. And if you are doing concrete jobs, you just don't stick joint sealer in there, because joint sealer is only good for a certain amount of depth. You need to sometimes get a backer rod, the foam backer rod. So if you're doing a 3/8 inch groove or a 1/2 inch groove, you want to buy the next size bigger of backer rod, because you're going to use your wooden dowel to push that backer rod down in over the cable. And then you are going to put that joint sealer. Sika makes a great joint sealer that a lot of professionals use for these applications. So what you're literally doing is you're cutting the depth into like a third that actual joint sealer needs to fill. So it's very, very important that you remember your backing rod when you're doing that one. So let's take a look at the finished driveway. What's going on here?
So that's already a finished driveway, a complete installation being done, and the picture taken during the first winter of operation. So as you can see now, you have a nice, clean of snow, clean of ice, snow-free parking spot. Perfect place to park the car. Easy place to easily get out of that driveway, maybe when it's some sort of ice storm or so. Especially if it's anything on the hill, you have the car nicely, safely parked on the dry asphalt. So it's perfect. Again, if it's electric, since it's an electric system, later in the seasons or so, you can always add on to that and maybe do the full length of the driveway, or maybe add on a nice walkway or so. So all that is possible.
Yeah, I just want to stress that this picture is kind of taken in the middle of its operation. It's not completely done yet. You can see where the areas are now starting to dry off. Eventually, once this is done heating, what happens is it does this first. So this is where the heaviest snow. And you can see someone's driven over it and carried snow from another area onto this spot. What happens is it melts it. Then what it does is after it melts it, it just doesn't stop, because then you would have ice forming there. So what happens is This one has got a little bit of a head start because a little bit thinner snow and ice over here. So what it's done now is not only has it melted the snow and ice, but now it's evaporating that water. And eventually both of these sides will have this nice dry look. But I like this picture because it shows you when the job is halfway done. When it's completely done, it'll be completely dry like this. So that's what's so good about this picture. All right, so we have, let me take a look here. Can this be used with driveway paving blocks? I'm going to start answering that. Thank you for this question. We do not suggest this because once you start cutting into paving blocks, they're going to start moving around. And then you're going to lose your polymeric sand connections to all your joints. So there's too many pieces moving around. This is done into concrete or asphalt because when you cut it, it's going to stay put. Once you start cutting little tiny pieces of pavers, then you're going to have them start moving around, and it's going to be very, very difficult to do that job. So I'm guessing in theory, the answer is you can try it, but after just putting in pavers myself, I know that you probably don't want to do this, and I would strongly recommend that you don't try it with paving blocks. So that's a very, very good question. We appreciate you asking that one. So let's go ahead and go on to our next one here. And hey, we just answered a question right before the slide says answer questions. So I love that. It's kismet. So what I want to do is to give you folks a chance to think of questions. You might be scratching your head and go, man, I've got a great question. I just need to type it in here. So go ahead and do that. We had a question from Diane H. And Diane asked, does it affect the life of the existing driveway? It shouldn't. But first of all, the driveway you should be putting it in should have a lot of life left to it. It's not going to be something you're putting into a crumbling driveway. Also, if you don't seal the grooves that you've cut, you're going to allow water and snow and ice to get down into those grooves. And we all know by looking at highways in the spring when they all start falling apart because ice gets in there, water gets in there, it expands when it turns to ice, and then it blows everything out. So you shouldn't really have any effect on your driveway if you get all of those seams that you've cut, all those grooves cut. You need to make sure all of those are filled and there's no water getting down in there and turning to ice. So that is a great question, Diane. The time frame that this took, Anatoly, do you remember how many days this took? It was kind of like one day for the cutter, and then the rest of it was done when the electrician came, right?
Yeah. I mean, it would really all depend on how
big it was, right?
How big of the area, of course, but also how each of the contracts were scheduled. So yeah, I mean, it would make sense probably if there is no rush on the project. It makes sense to maybe plan each of the contracts or each of those major steps on each individual day, just to kind of create a good schedule and make sure that everybody has time to do its own part.
Yeah, and part of that is you may need to have the cutter because usually the concrete guy is going to be, or the concrete installer is going to be one day. Then you're going to have an electrician who can possibly do that the same day. But the problem is once that cut is made, you then have to use the high pressure washer. You then have to clean the grooves out. So you might want to do that cut one day, have the electrician come in and lay out all the stuff the next day. And maybe at the end of the next day, you'd have the concrete guy come back and fill those grooves. That might be how you could reduce it to 2 days on a tire track like this, but it might be 3 days. Getting that concrete person or that asphalt person to come back, it could be a day or two or whatever. That's not a function of the installation. It's just a function of their availability. So we have a great question here. I'm going to check on it from Brent. And Brent says, if it's embedded in the concrete below the pavers, will it melt the snow? And yes, that's an application we do all the time. It's in our installation manual. So if you went to WarmlyYours.com and went into the snow melt section, you could find the installation manual. The installation manual shows you exactly how to install the system in a brand new installation because right now this particular thing we're doing is talking about retrofitting stuff in, but what is being asked by Brent is something that is a new construction type thing. So yes, we do have that, Brent. If you need any help finding that on our website, you can simply call us at 800-875-5285, and we will tell you how to get that information, and we'll email it to you. So great question.
All right. Looks like we also do have a question from
a lot of magic work over here. So we have a chat question. They're coming at us from different directions. But Anatoly, I'll let you go ahead and make your point before we go to the next one. What were you saying?
Yeah, I just noticed this one. Yeah, that Gordon was asking us also through the chat here. How do you splice to add onto a system that is already there? In other words, how do you expand, if I understand the Gordon's question correctly, how do you expand or make your existing system larger?
Right.
And
we need to make sure that we there's never splicing done.
Sure. Yeah, we usually don't like to use that term splicing. What we would use is we probably would call it to expand the system or so. But again, to answer that question, the way you expand it, you're still going to add on and install your heating mats or heating cables, but you connect those either to your existing relay panels, if it still has the capacity, or you just install a smaller or larger size additional relay panel to it, and you still keep the same controller. All you're really just doing is you installing a brand new system, an additional system, and you wiring that to your controller, assuming that all the electrical parts are planned correctly and additional relay panel is there if needed.
Yeah, so that's a great question, because Sandra D, the movie star, no, it's just D period, not DEE. But Sandra D has asked about electrical requirements, and the electrical requirements to heat vary on your part of the country. Certain areas of the country need less watts per square foot than other parts of the country do. And I know, Anatoly, you've just been working on a big project about watt density and snow melt and that sort of thing. So can you kind of give Sandra, we may be going into the rabbit hole with you, Sandra, here, but it's a perfect situation to talk about watt density, because different parts of the country need different watt densities than other parts. So how can you tell us about ASHRAE, tell us about airports, and tell us about different parts of the country, Anatoly?
Yeah. So there's historical data that is provided by ASHRAE in the ASHRAE standards, and to make it simple, all that lots of these numbers are all converted into a wattage per square foot density that is needed in each of those geographical locations, and typically they use airports. So like in Chicago, you need, if I recall it right, somewhere around 48 watts per square foot to melt the snow for, let's say, 95% of the time. And again, there's exact numbers for each of the scenarios, but I'm just giving you an example. While, for example, in what state we're going to pick, let's just pick somewhere in Nevada, it may need only 25 or 30 or 35 watts per square foot to melt the same to melt the same driveway, but assuming that, of course, there's less snowfall happening. So all these, there's lots of data, and eventually, as soon as we know the location of each application, we can look up and see if potentially alternative wattage system can be used there.
Right. If there's no data for the ASHRAE tables, if you live somewhere between two airports and you're in a mountain and both airports are in a valley, obviously your situation is going to be a little bit different. And that's why we've always quoted about 50 watts per square foot when it comes to snow melting. So getting back to Sandra D's question is, what about electrical requirements? First of all, you need to make sure you have spots available in your breaker panel, and you need to see what kind of amperage your service is in your house. If you have a gigantic driveway that takes 300 amps and your service at your house is only 100 amps, you're going to be struggling to find a way to heat that entire driveway. So it's very, very important that you realize you take 50 watts per square foot, and then you multiply that by the number of feet that you want to heat. So if you have 200 square feet, you multiply that by 50 watts. That'll kind of give you an idea of how much electricity that you're going to need. So great question, Sandra. And what you can do is you can simply make a sketch of the area that you want to heat, and you can just send it to us at WarmlyYours at info@warmlyyours.com. And what we'll do is we'll just figure it all out for you. You don't even need to figure it out. By the time we're done, you're going to have a smart plan. You're going to know how to install the product. You're going to know how many amps it is. You're going to know how many breakers you need. All that stuff is no charge, and you'll usually have it the next day after you send us the request. So great question, Sandra. And that's what the difference of watt densities is. So if Sandra lived in an area where it only took 30 watts per square foot to heat a driveway perfectly, and Bill G had one that required 50 watts to heat perfectly, then you can see 20 watts per square foot can make a big difference when you multiply it by 100 or 200 or 300 square feet. So that's where your question, Sandra, kind of led us down the rabbit hole, but it kind of lets us explain the different things that go into figuring out snow melting. So Brent is back with a second question. His question is just about as good, or maybe just a little bit better than his first question. And that is, I need to click on this to answer it. The question he had before was based on a job that he went to look at, that they had an existing concrete driveway that they were looking to add pavers over it. Well, first of all, the thing you need to remember is the cable needs to be within a certain distance of the top of the area you're going to walk on or drive on. So knowing that, Anatoly, what would your answer to Brent be about this existing concrete driveway? They were looking to add pavers over it. This kind of really isn't a retrofit. It's kind of like an add-on, right?
Sure. And if I fully understand the application, the way that project will typically be handled is that heating system will be installed over that existing concrete, but since the system needs to be fully embedded, it still will need to be covered with 1 to 1.5 inches of finished mortar, sand, or stone dust, and then eventually a paver is going to go over top of this.
6-inch paver, 4-inch paver, how deep can the pavers be?
Great question. Yeah, definitely don't go with a 6-inch paver, because 2.5-inch pavers would be a limit. We don't want to go any thicker than 2.5 inches just because of a proper heat transfer, because eventually you still want to have a good performance of the system.
So hopefully that answered your question, Brent. Your two-parter were two great questions. So thank you so much for participating. Do we have, it doesn't look like we have any more questions, but the questions we did have today have been great. They've been awesome. Thank you so much for participating in the Q&A part. And let's go ahead and talk about the next webinar. In our next webinar, we're going to be discussing making the most of LVT with floor heating, luxury vinyl tile, luxury vinyl plank, any of that luxury vinyl stuff that is out on the market now, which is kind of like taking over the market because of its waterproof benefits and that other stuff. It has benefits, but there are also certain things. I'm teasing. You can tell I used to be on the radio here. I'm teasing the next break. But you can tell that these products are easy to use, but they have their own issues with installation. So please join us at our next webinar when we're going to tell you what you need to watch out for and the correct way to install heat under these LVT floorings. So hopefully that was a tease enough for you to come back and visit us on October 10th at 1 p.m. Central Time. And we will talk all about everything you wanted to know about those types of vinyl products and installing them in your house. Also, we have a thing called daily training, and you can join us daily for more training with our Radiant experts. And we have this, since it's daily, we do it Monday through Friday, Mondays, Tuesdays, Wednesdays, Thursdays, Fridays. And that is Monday through Friday with different times there. And we have different scheduled topics for each day. So if you want to, if you're just starting, if you're a home center or a kitchen and bath or whatever, and you're just getting into the floor heating game, you can check out our website and see what topics are going to be covered each day. And then you can just simply join us on the computer and learn about the products that we're talking about, and then talk about those questions that you might have installing those products. And it's a great way for you to get your group together at a lunchtime or later in the afternoon. And that would be a great time to go over those trainings and also ask us questions. So the monthly promotion for this month in September is 20% off Environ Easy Mats. And the Environ Easy Mats are going to be on sale through September 30th. Environ Easy Mats are great for use under carpet in the US. They're also great for laminate and floating wood in the US and Canada. I'm going to kind of back off my tease that I did about LVT. Notice how LVT isn't mentioned here with these products. So the Environ Easy Mats are for carpet in the USA and laminate and floating wood in the US and Canada. If you want to learn more, visit WarmlyYours.com, and we'll be glad to answer any questions you have about that. And you know what? We do these webinars, and we do them. We try to pick as good of conversation topics as we can. But if there's something you would like to talk about, something you'd like to learn about, and it's not available in our recordings, that you don't see any information about it, because we have all of our webinars are on our website. If you just go to the video section, you can see them. If there's something there that you haven't seen covered and you want covered, just reply to the email that we're going to be sending you, because we do appreciate, we'd rather talk about what you want to hear about than just something we pick. So please let us know what those are. Also, if you want to contact us, we're available anytime, 800-875-5285. If you have installation questions, if you're in the middle of a job, what can they do if they're in the middle of the job and it's a Saturday afternoon, Anatoly?
I would just go for a 24/7 technical support. So definitely dial us up at 800-875-5285, and our technical support is available 24/7. It's just so much better and faster to just get a right answer, correct answer, and proceed with the right installation method or whatever that would be.
Awesome. So if you want to email us, if you have a plan and you want to submit the plan for a drawing of your driveway or whatever, you can send that to info@warmlyyours.com. Also, we are on the internet, as you might have guessed, because that's how you're watching us today. So feel free to join us anytime at warmlyyours.com, and we're on Facebook and also other kinds of social media. And the person working the magic over there, they are responsible for all that great content. So we'd like to thank Olivia for that. Thank you, Olivia. And we'd like to thank all of you for joining us today. We really appreciate you having us in as part of your busy day. And I'll let you close it out, Anatoly.
Okay, then until the next time, everybody, stay warm and be radiant.
See you later. Thanks for joining us.
See you.